Hello everyone, thanks for joining me. Today I am representing my final project on a respiratory syncytial virus, also known as RSV. My name is Harmandeep Singh and I am going to start my slides. RSV is one of the most common viral infection affecting infants and older adults and recently is based on receiving more attention because of rising case number and new vaccines. For this assignment, I choose an article that focuses specially on how the RSV proteins affect the immune system. I will be taking care about the virus itself, how it works, the symptoms it causes, the treatment available on situation here in Canada. And finally, my analysis of the research articles. Let's get started. Slide 2, virus in my article. The article I chose looked at RSV but not just the virus in general. It focused on the role of G protein. Traditionally, most research focused on the F protein, which is responsible for fusing the virus with human cells. But the articles argues that the G protein is just as important because it helps the virus attach to cell and also interferes with our immune system. So the main virus is the article is RSV and the G protein is big part of how the vaccine cause disease. Slide 3. RNA and DNA envelope. RSV is a negative sense single standard RNA virus knowing its genuine type of help to understand how fast is minutes and how hard is for the immune system to recognize. It is also an enveloped virus, which means it has a lipid membrane around the outside. That envelope helps the virus fuse directly into the cell of our respiratory tract. It also and means RSV is more sensitive and environmental condition because the envelope can be easily damaged with why RSV spreads the main through the close contact. Slide 4. When RSV enter the body, it mainly target as citation epithelial cells in our airways. These cells are responsible for moving mucus and trapped particles out of the respiratory system. When RSV infect the destroy these cells, mucus start to build up, leading to the classic RSV symptoms like sneezing and difficulty in breathing. The article explained that G protein helps to fuse, but the G proteins is what help the virus and find its target cell. Slide 5. Symptoms. RSV symptoms range the mild to severe. In many older children and adults, RSV just like a bad cold, running nose, coughing, fever, congestion. But in infants, especially those who under 6 months, RSV can lead to the bronchial, which inflammation of the small airways or phenomena. These condition can cause sneezing and shortness of the breath. It in high risk groups like seniors of people with immune problem, RSV can aggravate existing lungs issuing and lead to the hospitalization. Slide 6. Duration of infection. The typical RSV infection lasts about 5 to 10 days. Symptoms usually peak around days 3 or to 5 and then gradually improve. In healthy adults, recovery is usually quick, but in infants and older adults, the infection can last much longer, up to 2 or even 3 weeks, because of their immune system. Either are they fully developed or are they efficient. RSV can also damage respiratory cell for weak, which is why coughing and the long last even after the infection is gone. Slide 7. Current concern on in society. RSV continues to be major concern for hospital around the each world year. Million in infants or gets RSV and hundred of thousand require hospitalization. One reason RSV is challenging is because immunity after infection is not long lasting. People can get RSV over and over again throughout life and even through the usually handle to its fine infant, especially premature babies face serious risk. This keep RSV high on the list of priority infection for Global Health Organization. Slide 8. RSV in Canada. In Canada, RSV case gone up In recent season, during the COVID-19 pandemic, RSV circulation dropped because of distancing making, but once of the year is ended, immunity in the population was low. This causes surge as RSV cases, especially in infants. Several Canadian provinces reported higher than normal hospitalization for patient respiratory illness. Recent data suggests RSV activity is still fluctuating but staying at the higher season level than before the pandemic. Slide 9, treatment. One important thing to know that RSV doesn't have the direct arrival cure of most patients. Treatment is mainly supportive. Doctor focus on hydration, keeping oxygen levels stable, and clearing mucus from the airways. Infants may need starting because they clear the mucus well in their own. In hospital, some patients may get replaced hypothetical saline in help to lose mucus. Oxygen therapy is also common on basis in distress. Slide 10, antibiotic treatments. While we don't use arrival antiviral medication for typical RSV infants, we do have both special antibiotics treatments. Flizulum is the monolocal antibiotic given mainly to the high-risk infants. It limits RSV F protein and prevents several infections. There is also a newer long-lasting antibiotics called Nevislam protection of RSV reason. These treatments don't cure RSV, they prevent serve disease in high risk groups. Slide 11, vaccine. Slide 11, vaccine. Vaccine have finally become available for adults and pregnant people. The vaccine are also protein based, not RNA. They use stabilized for the most RSVF proteins called the pre-fusion F protection. Older adults can also these vaccines directly, or pregnant people can receive them so that the protective antibodies pass to the infant before birth. These vaccines greatly reduce the chance to serve RSV disease in babies and seniors. Slide 8, main message of article. The article main message that RSV protein plays a much bigger role in immune suppression than we used to think. The G protein doesn't help the virus attach to the cell. It also interferes in the infection production, which is usually our body first arrival defense. It use it it used its CX3C motif to bind the human repeller called CX3CR1. Because these features and G protection can increase inflammation but also helps RSV avoid being cleared. The article suggested that make RSV disease worse to complaint vaccine design. Sorry. Slide 13, agree or disagree. I mostly agree to the author. The claim about the G protein, they are also well supported by evidence and the match what we know from other studies. The idea that the G protein manipulate the immune system, it consists with a lot current research, but I do agree with how strongly the author caution against but the G protein in vaccine. They base on early trials where G protein vaccine cause regressive immune response, but those were the technologies. With more modern vaccine engineering, I think there is still protein for the safety targeting the G protein also. Overall, I agree with the main point, but the thing is that there is a concern about the vaccine are the bit too strict. Slide 14, article reference. The author of the article did provide a solid reference. It includes studies how G proteins interact with the CXCCR1 and how its substances interfere with the G protein defect RSV trace behave. This make the article more reliable because of evidence is visible and can be verified. It includes screenshot on the slides how that the article clearly cited its source. Slide 15. So this is so as we know this is a reference slide. These are the full of reference I used in my preparation. It include reviews on RSV, immunology, global case member treatment strategies, and vaccine developed. All of them are open case source. Using this allowed to me to beyond the original article and build a more complete understanding of RSV and the more role of G protein. Thank you for listening and the conclude my presentation. Thanks and have a nice day.